You may have heard of the psychological concept of flow. If you're a business analyst or data engineer, the tool EasyMorph can put you in a flow state unlike any other data tool. But what do I mean by flow? Well, if you've ever galloped on a horse or glided down a hill or written a poem or given a live performance or have been entranced by a video game, then you would be in the throes of a flow state. Flowing, or elan as the French would say, are when we are happiest, most alive, and as far as business goes, most optimal. In a flow state, we can solve problems in just a few minutes or hours that might otherwise take days. So what is EasyMorph? Well, EasyMorph is a business automation tool for data preparation and analysis and is often compared to other data tools like Alteryx, PowerQuery, and even scripting languages like SQL or Python with data frames. What distinguishes EasyMorph from these other tools is that it allows you to enter and sustain a psychological flow state more quickly and more intensely than any of the other tools that I've ever worked with. Simply put, if you work with data, whether it's in Excel or another data prep tool, EasyMorph is a joy to use, unlike any other tool. Well, what do these other tools do? Well, these other tools, including Excel, allow business analysts and data engineers alike to clean, integrate, and shape data for the purpose of producing reports and answering unexpected questions, often at executive speed. So what does this have to do with flow? Well, flow states have a natural enemy: slow feedback, disorientation, and context switching. The reason EasyMorph is so well suited for data tasks come down to three main design features that are inherent to the tool. First, fast feedback. Second, table orientation. And third, synchronized development and analysis. Well, how so? Well, first of all, EasyMorph responds in sub-second time for the vast majority of operations because it is a so-called thick client that leverages your PC's RAM and cores. It's the same reason Adobe Photoshop and Autodesk Maya continue to also be thick clients used by professional graphic designers and animators, while web-centric thin clients are often hampered by the inherent slowness of networks and servers and mainly exist for the benefit of system administrators. Second, EasyMorph is anchored in data tables showing rows and columns as opposed to scripts or process flow, so you can see at all times how the data is being modified at every step of the way. Third, and most importantly, EasyMorph has broken down the barriers between data development and data analytics, allowing you to interactively analyze all data at any step of development. Gone are the days of having to export data or build side reports for debugging data pipelines. For these three reasons and others, as you will see, with EasyMorph you can really get into the zone and stay there. So how will we demonstrate all of this? Well, our first and second video, or chapters, will describe the business challenge we are trying to solve and we'll go over the raw data. The third, fourth, and fifth videos, or chapters, will show us solving this challenge step by step by using EasyMorph. In the last three videos, or chapters, 6, 7, and 8, we will compare and contrast EasyMorph against three different tools, each with their own distinct approach. These tools are, first, Microsoft Power Query and Power BI, which takes a more table-centric sampling approach and is similar to Trifecta. Second, Qlik, as in Qlik Sense and Qlik View, which takes a more script or code-centric approach and is similar to SQL or Python with data frames. Third, and finally, Alteryx Designer, which takes a more visual workflow-centric approach and is similar to traditional ETL tools like Informatica or Dataflow, or Azure Dataflow, I should say. But before we get into those videos, I must caution you that there is a flip side to flow states and tools that bring us joy. Once you become highly proficient in a given tool and can play it like a musical instrument, then the tool can become an extension of yourself. This effect is known as Maslow's hammer, or more formally, the law of the instrument. You could, for example, do everything in a low-level procedural language like C or a spreadsheet like Microsoft Excel, for that matter. But when it comes to querying data, the declarative SQL language is much more efficient and allows you to focus more on the essential complexity of a task without getting bogged down in so-called accidental complexity like memory debugging in C or confusing cross-worksheet cell references in Excel, for example. But some people will never make this leap because they're so proficient and comfortable with C or Microsoft Excel or whatever the tool might be. By analogy, you can get into a flow state just from walking. So you might prefer to use snowshoes to cross a snow field, and you would eventually hit a stride and get on a roll and happily cross that field. But you would also be able to cross that same field much faster on a snowmobile. And once you got comfortable with the snowmobile, you would hit your flow state faster and more intensely. On that note, let's get started with our EasyMorph demo and the tool comparisons. Okay, let's start looking at the raw data, and then we'll start to clean it up. So the raw data files, there's three of them. There's first fictional technician, second is fictional business, and the third is fictional dispatch, which connects the technician to the business. Now, there are a few data quality issues we have to deal with before we can really get down to analysis. The first is the technician has a couple issues. It has these kind of funny asterisk characters. There could be other spurious characters in there as well. Sometimes they're reflected back in the main technician file, but often they're not. The other issue is that we have some duplicates like this one here. We can actually identify the duplicates using this technician dedupe field, so that makes our lives a little bit easier. The other issue that we have is in the fictional business table, there are some blank businesses. We want to make sure we're filtering those out because otherwise it will skew our analysis. And just as a precaution, we also want to deduplicate our business ID, just in the off chance that there are duplicates in here. And let's get down to business now and start cleaning these up with EasyMorph. Okay, let's start with cleaning the fictional technician data. So to do that, we just need to drag that fictional technician data in here. And right off the bat, we can really easily do some powerful data profiling. So you can see actually just by looking down here that we've got 149 rows, 7 columns. And we can also go into what's known as analysis mode by maximizing the window, and we can drag fields like this out here. You can see right off the bat that this field is telling me that everything is unique here, whereas this field here, technician dedupe, is not, kind of as expected. I can also look at the table metadata as well and sort of see right here that yes, this is the only unique field here, and you can see all the distinct values of the other fields. So it's, and the data types, and how many um, uh, values of each data type you've got. So postcode, you can see you've got 119 numbers versus 30 that are not. So right off the bat, it's very easy. I can also, even when I'm here, do things like analyze the data like this. So search for all of the technicians that begin with that star and even just select those. I could then go in and select the complement of those from this column here. So I could say select excluded, and then by clearing this and clearing this, I can see here that I've obviously selected the excluded. So it's a very powerful analysis right off the bat. We're going to come back to this analysis view later on. But when I leave analysis view, any sort of analysis I do in there, any filtering, it's just ephemeral. So we're back to normal when we're in this view. Now we're going to want to deduplicate this table, but we want to do so using a Derive table because we actually want to refer back to this original table at a later stage when we're cleaning our dispatch data. So I'm just going to derive a new table here, and you can see instantly that it is derived. It is coming from this table. We can even just rename it as well to make it a little bit easier, and I'm going to call this dim technician to keep track of what we're doing. And from here, we can go in, and all I really want to do is I want to take this technician column, remove it, and rename this technician dedupe column back to technician, and then dedupe on that column. So we'll start with removing that column. And you'll notice right away at the left and at top, there's a new little icon that's shown up here. This shows me the action that I've just performed. And you can see all of the actions here, or you can click into an action and get its details. So this is what I also really love about EasyMorph. I'm anchored in the table, but I can see the control flow. Then I am going to rename this. So I'll just do it from here. By the way, you can add actions from this explicit action list, or you can do it implicitly like I've just been doing so far. Now I'm actually going to do a a filter. Again, I could do it from here, but I'm going to do it implicitly because it's just a little bit easier. And I just want to filter out all of the duplicates, remove rows, remove duplicates. And finally, the last thing, and oh, before we move on, I can tell you, we can see right away that the duplicates have, at least one duplicate's gone because we've got 148 rows. And we can go back here and we can see that there's 149. So this is another really powerful aspect of the tool. And the last thing we want to do, and here I'm going to just add an explicit action. I'm just going to export this to another CSV flat file. So I'm just going to choose my desktop, and I'm going to call that dim technician. And I'm going to hit save and apply. And as soon as I run that action, I'm just going to run that action like so. The file has appeared, and I'm just going to, it's on the other part of my desktop here. And so we can just quickly tell, yep, this is the new output, looks good. And we're good to move on to cleaning to the dim business. Okay, now let's clean up the fictional business table and create dim business. So before we do that, we're just going to clear up, move this out of the way a little bit. We're going to minimize these windows. And we're just going to drag in the fictional business. Now, dragging in is not the only way. The standard way actually is just to click this Add Data button, and we could have just chosen Import Delimited File, but we did it the way we did it. So we want to clean up this business file. The first thing we can do is, again, check to see how many rows there are. We can see down here there's 862, 10 columns. We can, first of all, let's just get rid of any of the, and I just want to quickly look at this to see what the data looks like. We can see that obviously it's not unique. We can see that there's a blank row in here. So let's go back and clean up that blank row and then also remove any duplicates in here because it looked like there were a lot of duplicates in there based on that profiling. So I'm just going to do some filtering. I want to remove the selected, so I'm going to create a filter based on that. You can see over to the left here, it's created that step for me. And now that I've removed that blank row, I just want to remove the duplicates. And you can see here my row count's gone down to 507. So removing those blanks, it took it from 862 down to 860, now down to 507. And we're basically done. So we're just going to export this as another flat file. So we're just going to add a new action and export into delimited data. And I'm going to call this dim business. Save that like so. Hit apply and run that action. And now I have my dim business table. We're just going to go drag it over from the other part of the desktop, and I can quickly check it here. And how many rows do I have? Yes, it looks like I've got 507. How many did I have according to EasyMorph? 507. Okay, so it did exactly what we were expecting it to do. So okay, so now we want to clean up the fictional dispatch table. So before we do that, I'm just going to minimize the fictional business and drag in fictional dispatch. And just start off with a little bit of data profiling. So we can see right off the bat that there's 16,411 rows. If we go into the table metadata, we get a sense of, how many distinct values there are in every single column. So what we want to focus on first is cleaning up this technician field. As I mentioned earlier, there's quite a few instances where it's not going to match because of these asterisk characters, perhaps other reasons. So the first thing we need to do is perform essentially a join or a match, a fuzzy match in our case, or a fuzzy join with the raw fictional technician data. To do that, we're going to add a new action. It's going to be a fuzzy match, so I'm going to type in the word match. I'm going to select this match, and we are going to select from the column is technician, the lookup table is fictional technician, and a lookup column, of course, is the technician, and the match mode is going to be fuzzy. So if there is no match, we can just make it empty just to be safe. And you can see here it's drawn a little line in from this table. It's a dotted line. It's showing me that I have done this match. Now, having done this match, now I'm in a position where I can perform like essentially a VLOOKUP to return the corresponding technician dedupe field, because that's ultimately what's going to be in this dim technician table. So I'm going to click new action again. I'm going to type in lookup, and we're going to use that step. So the lookup table in this case is going to be back to my fictional technician table again, and I'm going to be matching on technician as you would expect, but I'm going to return the technician dedupe field, and if it's not there, I'll just make it empty. And boom, now I have my technician nicely mapped there. Now I want to also perform a mapping on my, or sorry, a matching on my business as well, just in case there's any businesses that don't exist in the uh, dim business table. I just want to be able to filter them out. So again, I'm going to add in a matching step here, and I'm going to choose that. And the column I'm going to be matching is the business ID. I'm looking up against the fictional business table, and the lookup column, of course, is business ID. And I'm going to do a fuzzy match again, and I'm going to make it empty because, again, I want to actually clear out those rows that don't have a corresponding business ID. So now I hit apply. You can see now there's a dotted line coming in from fictional business. So it's telling me again that there's kind of a relationship here. And now that I've basically done that, I can start to filter this out. So I've got 16,411 rows. I'm going to filter on this business ID, and let's see how many rows I'm left with. So I say filter, and I want to remove the empty ones, and I create filter, and boom, instantly I can see I'm down to 15,923 rows. So I've got my clean data now, and I'm good to export back out into a flat file like a CSV. So let's just call that fact dispatch and hit save and apply. And I'm going to run that action. And before you know it, we've got our new fact dispatch table. Just going to drag that back over here, and it should have 15,923 rows. Let's just see how it looks. Just open that up. It takes a little bit longer. It's a bit of a bigger file. There we go. 15,923 rows. Yep, with the header, that's exactly right. So we're good. Now we've got a set of 3 clean data files that we can use to derive our new dim visit. And we're going to work on that now in our next step. So let's just get ready for that. All right, now that we have cleaned our data, we are in a position to derive our visit number. But before we do that, let's hop into Excel to just see what the output looks like that we're trying to generate here. So I've already pre-created the file, but we're going to just go through the steps to do it again. So as you can see here, you've got this technician, the business that person's visited, and I've derived this field visit tuple where I've concatenated the two so that anytime for a given visit date, it increments, the visit number also increments. So you can see here the first 3 dates for this tuple here are the same, November the 2nd, but once we hit November the 9th, it increments by 1, so that goes to 2, and then it increments again on the next date, it goes to 3, and so on and so forth, all the way to the bottom. So let's just jump back into EasyMorph here, and we're going to create a new module. I'm going to call that Derive Visit Num. And an EasyMorph module is basically self-contained for the most part, so anything you do in the module won't spill into the other modules, but it is possible to run the modules in sequence as an entire program. So let's get our data in this module here. So I'm going to just drag our clean fact dispatch that we just spent time cleaning up. And the first thing I want to do is derive that visit tuple field, the one I just showed you a moment ago, this one right here. And to do that, I'm just going to right click on next to the column I want to insert next to. So I'll say insert column, and I'm calling that visit tuple. And I'm going to jump into our expression editor. And all we're going to do, as I mentioned earlier, is just concatenate the technician to use the concat operator, put a little pipe character in between to make it more readable, to the business ID, like so. And now we have our new column. We are now in a position to derive the visit number, and we're going to do so as a separate table, mostly just to kind of keep things clean and easy to understand. I like to have things well oriented. So let's just add that as a new table. And we really only need the visit tuple column and the visit date to derive that number. So I'm just going to remove all the other columns by just selecting those two columns. And we got to do a couple things before we actually derive that column. We've got to first remove the duplicates, because if you recall, we don't want that increment to happen when it's the same date. So to avoid that, I'm just going to remove all of those duplicates. And the second thing we need to do is make sure that we're sorted in the correct order. So I'm just going to sort by this column, and I'm going to add this column as a sort column as well. And now we're in a position to add that enumerated row. Actually, before I do that, I'm just going to quickly rename this table, because I just like to keep track of what is what, and it's just much cleaner that way. So I'm going to call that visit num. Now we add the our enumerated row action, and this really does the magic here. And this is really where I think EasyMorph shines, because not merge, when did I say that? I said enumerate all rows. And you can see it's already done this. It's already added an incrementing row, but we want to increment within the same tuple here. So we want this to go back to 1 again. So that's easy to do in EasyMorph. We just say we want to enumerate within groups, and we select our visit tuple as our group, and boom, it looks just as we would want it to. Last thing I'll just do here is just rename that column, and I'm just going to call that visit num. And now we're in a position to essentially join or merge it back into our original fact dispatch table. So to do that, I'm just going to derive a second copy of this table over here. I'm going to rename this to be fact dispatch v2. And that's just so we can keep track of it. It has nothing to do with what files are going to be written or anything like that. This is just internal to EasyMorph. Now that I've done that, I can now merge it with this table. So I'm just going to add the merge action and merge another table, and I'm going to of course merge from the visit num. It's already figured out what columns to merge or join on, and I've got a choice between 3 merge modes. There's the lookup, the left join, the full join. Lookup is similar to a semi-join, so you're never going to get duplicates. It's kind of the safest way of doing merges. Left join, it's kind of like SQL, but of course that can sometimes lead to fan traps or duplicates, so I'm not going to bother with that. And let's just proceed with the lookup. Of course, we want to make sure we're bringing back our visit num column that we've just added. So I'm going to hit apply here, and boom, my new column is been added right off the bat. I just want to drag that to the beginning. So I actually just need to drag it a little bit to create the step. And then once I've done that, I can just say move to the leftmost, and there it is. So now I've got the data in how I like it, and I just need to output it to a flat file. So I'm going to add a new action, export to delimited file, and I'm going to choose the desktop again, but I'm going to call that a v2, not to confuse it with my original file. And I'm going to overwrite in case it's already there. It's not. And finally, I run that action, and I can see the file has appeared as fast as I press that button. I'm just going to drag it over here, and let's just take a look at that file quickly. So there's the file. Just going to filter on that first technician like we had earlier, and just do that. And then I'm going to sort by the business. And finally, I'm going to format that date field because it's being presented as a number. That's fine. It's easy to do this. And finally, let's take a look at the data. Is it corresponding to the dates as we expect? Yep, that's repeating. So that's visit number 1. That makes sense. 2, 3, 4, 5. Okay, that's perfect. We got it done. So now we're in a position to do our final analysis and see if our hypothesis is true or not. Okay, now that we have derived our visit num, we are in a position to complete our analysis. So I'm going to add another module called analyze visits. And as our source data, we're going to use that fact visit v2 that we just created. And what we need to do is, because we're creating a chart, and just to explain quickly, the chart we're deriving is going to show the percentage of unscheduled time by the visit number. And it's also going to show the number of visit tuples also by visit number, so that we can establish some confidence. Now, to do that, the first thing we need to do is, essentially what we're doing is creating like a pivot table or a chart, dimensions and measures. So we need to aggregate our measure, and then we can aggregate our then we can build our charts essentially. So I'm just going to right click on the column, the first column that I want to aggregate on. So that's going to be the normal time dollars. And I'm going to say aggregate. I just want the sum of that. Now I want the sum by visit num. So I'm just going to choose that right off the bat. And you can see here, it quickly tells me what the total number of normal time is by visit num. So we just need to modify this to add a couple more aggregations. So we're going to add the extra time, of course. And we're also going to add I meant to add it from here, the extra time dollars. And I'm also going to add a count or a distinct count of the visit tuples. And I'm going to call that count distinct. And I'm going to rename that, call that num visit tuples. So we're almost ready to do our analysis. We need to calculate the percentage of extra time, of course. To do that, we just need to divide the extra time as the numerator by the normal time as the denominator. So that's easy enough done as a derived column. So I'm just going to write here and say insert column, and I'm going to call that percent extra time dollars. And I'm going to go into my expression editor. I'm just going to select the extra time divided by the normal time, and boom, now we have our percentage. So we are now in a position to visualize. So I'm just going to add a new chart here, and I'm going to derive this chart in a new group that I'm going to call charts. And a group is just another area within the same module. It actually will run as part of the same module, even though you might not see it right away. So there we go, that's charts. And I'm just going to add, obviously, as my category is the visit number, and the series is going to be based on the percent extra time. And let's just give this some color and make it into a line chart, maybe increase the dot size, and boom, we have our chart, and this is exactly what we expect. We can see here, just to do some analysis, that the first visit is taking up 75%, and that's dropping to 40% on the second visit, and then by the third, it's at 25%, and then it starts to go down to about less than 10% after that. Now you see here there's these interesting spikes, and that's a little bit worrying, but let's bring in the second chart, which is going to tell us how confident we can be in our analysis. And we're just going to go back to our first group here, and I'm going to derive another chart, or sorry, I meant to say I want to derive another chart, and I'm going to just derive it right here for now. And again, our category is our visit num, and our series this time is going to be the number of visit tuples. And I'm just going to move that into the other group. And now that we're in the other group, we can sort of stack these charts on top of each other. And what's immediately obvious is that this chart here has 965 versus, once we get to these higher number of visits, there's just barely any of them. So there's no confidence in this number here, just based on the tiny population, whereas there's a fair amount of confidence, like it's an over 90% confidence once you've got over about, even 400 or so. So we have a decent amount of confidence. And so this trend, this pattern, in my view, and I'm not a statistician, has a lot of weight to it, because it's really showing us that the more experience a technician has visiting a business, the less likely it is that they are going to request extra time. So if I'm managing the overall operation, I would try to send the same technicians back to the same business. Now, obviously that's common sense to some degree, but here we can kind of quantify the cost if we don't do that. So it puts a bit more of a deliberate pressure on avoiding sending technicians out to a new business and trying to get the technicians that have already visited the business to return. So mission accomplished, EasyMorph. Thank you so much. This has been excellent. Okay, now let's take this demo we just produced in EasyMorph and compare it to the same demo but prepared in PowerQuery and Power BI. So let's just first open Power BI, which contains PowerQuery. And once that has been opened, we will, there we go, that's Power BI. Just going to minimize that for a second, and then let's open EasyMorph. And it showed up in the other window there. Here's EasyMorph. And I'm going to minimize that. Let's just jump back into Power BI. And to get into Power Query, normally you would just start by adding data, but since we already have a load script, we're just going to jump into Power Query by hitting this transform data button, or you can click here like so. And now that we're here, this is Power Query. Now, the first thing you can see here is it does have, the good news is it has a kind of a visual metaphor in terms of being able to click these buttons, and which kind of have nice visual icons that generates the code that you'll see to the right here. So this was all generated using these visual metaphor steps that you can see. The other thing that I really like about Power Query is it is oriented around the tables. So that's, again, what I love about EasyMorph is it's anchored in those tables, and that really contributes to a flow state. But on the negative side and the con side, that flow state in Power Query doesn't really arrive the same way because of the lack of fast feedback. And what I mean by that is, and you get a sense here, there's a bit of a lagginess. And if you talk to a lot of Power Query developers, they will all kind of tell you the same thing, that you can often spend a lot of time waiting for these things to finish. And there is a way of actually controlling for that. You can go in here, and under options and settings and options, there is this data load option, and you can see here there's a section called background data, and you could actually turn off the previews so it won't constantly refresh every time you click around. But that's kind of defeats the purpose of Power Query, because that's kind of the nice thing about it, is it shows you what the data looks like after you've made a transformation. So you wouldn't want to turn it off. Now, by comparison, you can see here it's kind of lagging on Power Query, but if I jump into something like EasyMorph and I run all actions, you see how fast that was refreshing? And the same thing here, I can run all actions and boom. So why is Power Query so much slower than EasyMorph when it comes to refreshing data like this? Well, the answer is, I think, twofold. I think the first reason is that Power Query is built on a technology called HTML5, and it's really been designed to work in a web browser. So whenever you have these desktop tools that are really designed to work in a web browser, sometimes they can actually be even laggier on the desktop than they would be working in the web. And that's one reason. But the other reason is Power Query was designed to work with big data, and that was actually very common with a lot of other tools around the same time that Power Query came out in the early 2010s. Another tool that comes to mind you may have heard of is called Trifecta, and it was built from the ground up to work with big data, databases like Apache Hive or Google BigQuery, where you potentially have billions of rows. And when you have hundreds of millions or billions of rows, you don't want to work with them all at once. You want to basically work with these things using just samples. So you can get a sense of that. If you look at the bottom here, you'll notice it says here 20 columns, which is nice. That's what EasyMorph tells us. And then 999 plus rows. And then it says here, column profiling based on top 1,000 rows. And what it's really doing is it's literally just sampling the first 1,000 rows of the data. That's fine in some regards, and it's true. If you were working with billions of rows of data, that's not a bad idea. But I hate to say it, most people don't work with billions or even hundreds of millions or even tens of millions of rows of data. Most people are working with much smaller sets of data, or if they do need to sample, they're going to sample ahead of time and they're going to find a representative sample. And the reason I'm pointing that out is one of the challenges that I routinely run into with Power Query is if I need to do a transformation that depends on a value of a field, like it could be a transaction type field, but it could also be something like this. And I need to filter on a specific person or a specific type, and it's not in this list here based on the sample. I mean, all I can really do is click this load more button, and cross my fingers and hope it shows up, as they increase the sample size. But if it's not there, I'm kind of stuck. Now, what I do have an option, which is I can jump up here and I can start writing code. Now that's kind of a last resort for me. Now I've taught Power BI and Power Query courses, and what I teach is I tend to encourage people to stick with the visual metaphors, to stick with clicking up here, because you know the code generated is going to be clean and it's going to be safe and understandable. But that code that's generated by clicking these buttons up here, and there's more of them up here and even here, it comes out as text. So if I'm trying to understand something like, okay, well, where are my joins or where are my filters? I literally have to read down here. Oh, they're filtering rows at this step here. Whereas if I go into a tool like EasyMorph, I can click and see, oh, well, this is clearly a filter icon. So I have that visual metaphor that just makes it very, very fast and efficient for me to scan through the code and see what's going on and pick out things like filtering. Whereas in Power Query, again, I have to do a lot of slow textual reading to get the same job done. The other challenge that I have on that same note is occasionally I am forced to go in to the underlying code. Now, if you recall, in EasyMorph, I was able to generate that enumerated row number that sort of increments every time the visit date changes. And I can do the same in Power Query, but it was a lot more tricky to do. And you're kind of seeing the steps execute here, by the way. You can again see that sort of lagginess. So I was able to generate this visit ID number here, but in order to do so, I had to sort of paste in this piece of code that I wasn't able to generate using any of these visual buttons up here. I had to go onto the community forums and find an example, and then take that example and then parlay it into this advanced editor here. And as you can see here, this is a language called M as in Mike, and it is a language. It's a functional programming language, but it's not got a lot of formatting, and it's not the most developer-friendly language, I would say. So it is a little bit daunting anytime somebody has to jump in here. Even myself, I tend to avoid it. Now, the last thing I'll say on that regard is Power Query. The other challenge I have with Power Query is it's not modular, meaning that I can't create intermediate output files like CSV or even Excel files. All the data has to be loaded into Power BI. It's kind of like a one-way street into Power BI. So this meant that all those cleaning and derivation and then deriving the aggregates, I all had to do them kind of at once. And it made my code a little bit more complicated than I think I would have wished it were to be. So it's nice if you can kind of break things up into little pieces, because it becomes easier to support. Now, the last thing I'll mention in Power Query and Power BI is there are two ways that you can kind of combine data. There's the merge, or it's kind of like a join, and the other way is more like what you might call linking or semi-join, or EasyMorph language, it's more like a lookup. And that's exactly what I did here, and it worked. And I was able to get the chart, and you can see here I've got the same totals as I do in EasyMorph. So we can see here that 74.94% and 965 as the count. And if we go into analyze visits, we can see here it's 74.94% and 965 is the total there, and all the rest of the numbers are the same too. I can assure you of that. So we got the answer we were looking for, not in the way we were hoping to get it. And the reason I'm pointing this out is normally what would happen is IT would just step in and say, oh, don't worry, pretty little head. We can take it from here. We'll put it in something like, Azure Synapse or Azure SQL Database or Azure Data Factory or maybe a Spark notebook. And at that point, the business user essentially can't really easily make changes on their own anymore, and they've lost control. So my advice is, if it's possible to use a tool like Power BI with EasyMorph as opposed to using Power Query, you will get your job done much faster, and you won't have to rely on IT, and it will be much more of a joy to do that work. So that would be my advice if it's possible. If not, I get it. You don't always have these choices, but if you can get EasyMorph working with Power BI, a much better way of working with data. Now let's compare EasyMorph to QlikSense. In particular, we're going to use QlikView, although the scripting language is the same for both QlikSense and QlikView. So let's just start by opening up each application, get a sense of the load time. And you can see here, it loads pretty quickly. Just load EasyMorph for comparison, and also loads in about the same time. So they're both pretty quick. That's good. So let's see, we can see the chart here in Qlik is producing the same totals as we're getting in EasyMorph, so we can just confirm that here. And sure enough, it's the same. So that's good. Now let's look at the code and see how this data was actually prepared. So we're going to jump into the scripting language. Now you can see here, Qlik scripting language is very much like SQL. So I'm kind of using Qlik as sort of a proxy for SQL, or even Python. Pandas data frames is similar to this as well. So the good news is that, a lot of people, they just prefer code. Text editors can be very powerful. You can reuse code. But I have to point out there's a couple caveats when you're dealing with data projects that are different from most other coding projects. The first thing is that data code tends to be, like SQL, tends to be a declarative language as opposed to a procedural language. So that really means that you're dealing with the whats instead of the hows. So you don't have to worry about things like while loops or for loops or branching logic or subroutines. You're really just specifying what you want. And for that reason, there are fewer repetitive patterns in declarative code. It tends to be much more, I guess, random in a way. The other thing is that you can see here, most of the code is literally just field names. So that too kind of undermines your ability to reuse past code templates. And as a result of being reliant on code, now we're getting into the problems of code, especially with data projects. So code in general, there's lots of benefits, lots of advantages. Great for software development, but again, for data preparation, data manipulation, not as great as a tool like EasyMorph, for sure not. Orientation is an issue. It's obviously not oriented in the data. It's clearly oriented in the code. I mean, I can jump in here and see a table viewer at the end of the run, but if I'm required to look at debug a table in the middle of the run, it becomes a little bit more difficult. And we're going to jump in and do an example of some debugging there in a second to see what that looks like. The other issue is that code itself can often be more difficult to simply understand and learn. So if you're taking this over for the first time, you might struggle to understand how I did some of this fuzzy matching. And just to kind of summarize what I did have to do, basically I had to isolate the non-matching, or the values that didn't match precisely, and perform a cross join with those values with all the other values, and then from there perform this Levenshtein distance, use this Levenshtein distance function, which is essentially just a calculation of similarity. So to give you an example of what that looks like to debug, I'm just going to uncomment this code here, which is essentially going to do two things. It's going to write it out to a flat file, which is a traditional way that a lot of people debug these types of things, and we'll look at that. And I'm also going to break the script here so that I can actually just use Qlik itself to debug. So let's just save that and reload. And of course, as you would imagine, our data disappears here, but that's okay. We're just going to create a little debug table. And we can see here, this is the intermediate fuzzy matching data. We can also see it if we look on our desktop, because I wrote it out to the desktop here, and there's the same data here as well. So if we try to debug in a tool like Excel that's outside of the main tool, we're context switching. So that's, again, something that breaks that sort of flow state. But you can kind of debug. So if I go in here, for example, and you get a sense of how this fuzzy matching is working, I'll take the lowest values here. And actually, you know what? I'm just going to sort by the smallest to largest. And you can see here that the fuzzy matching actually works quite well, because we can see that the similarity score is 1. And then Once we go up to 6, you can see here, oh, they've got the same last name, their first name is different. So it's kind of nice in that it does show you how the sausage is made if that's what you want. But most of the time, actually, I really don't care how the sausage is made. So the more low-level coding aspect of this tool is, to me, not all that enticing anymore when I'm using tools like EasyMorph. I'll also show you another little code snippet here of where we're deriving the visit ID number. If you recall, in EasyMorph, we derived using this enumerate rows, which again was really easy to just add and configure, and anyone taking over this code would very quickly understand what it's doing. Doing the same thing in SQL or SQL-like language is not always the same. Sometimes you have to do what's called a self-join. In this case, Qlik has these inter-row functions like previous and peak, and they have little quirks to them. And that's the other thing about coding, is that you can be off just by, you miss a comma here, or the quote's not the right way, or you didn't understand the difference between peak and previous, and you get these vastly different results. And so you have to be really, really careful when you're coding not to make these small errors, because they can have huge ripple effects. So that's the problem with coding for a business user, is that most business users will hit a limit, and they will eventually find it difficult to keep up with the code, and they'll call IT for help, and IT will in turn provide that help, but in turn they will take away the code, they will manage it, and essentially it becomes calcified. You can't really make changes anymore, and you lose control. So again, a tool like EasyMorph puts the business analyst in way more control than any IT department, because the IT department again requires that you go through change requests and all of that rigmarole. So that's another reason why I'm a huge fan of EasyMorph, and it can work hand in hand with BI tools and data visualization tools like QlikView and QlikSense. Okay, in this final video, we're going to take a look at Alteryx and see how it compares to EasyMorph. Now, the first thing you'll notice actually is I have 5 Alteryx documents. That's because Alteryx splits each data pipeline into its own document, but that's fine because you can also open them all up in the same window, as you'll just see in a second. So let's just open up Alteryx here. It loads relatively quickly, as you can see. And there we go. That's our first pipeline that we've just added. Just close that splash screen. And let me just open up we'll just move this window back here, the other pipelines. So I'll open up that one and the other one, the Derive visit number, and finally the analysis. So these are all our pipelines. And let's just take a moment to take a look at how Alteryx is fundamentally structured. So Alteryx is, as you can see here, anchored in this visual metaphor, boxes and lines. You can click on any of what they call tools, what EasyMorph, I guess, calls actions, and see how it's configured. So that's quite nice. It's very interactive. It's very similar, actually, to an ETL tool. If you've ever heard of Azure Dataflow, or some of the older tools are like Informatica, DataStage, Pentaho Data Integration, SSIS. If you're familiar with any of those tools, you'll recognize EasyMorph's paradigm, and it's quite a popular approach. I have to say, I think there's a lot of appeal to it. EasyMorph, of course, has also a visual metaphor approach as well. In fact, if you just want to focus on the visual metaphor, you can actually minimize the data tables, and of course you can see how things are configured, just the same as EasyMorph. So the tools are very similar in that regard, in that they both support this visual metaphor. They're both relatively quick. Let's just run this through to get a sense. Statistics, the number of rows that are coming out of each, well, they just disappear, but you could see them there for a second, out of each of these, what they call tools. Now, what I want to get into at this point is to show you how the two tools diverge. But before I do that, I want to spend a little bit more time sort of showing you the benefits of Alteryx. So Alteryx, on its strong side, does have quite a long list of what I'll just call features. And you can see here, I'm just browsing through some of these features here: spatial, text mining, machine learning, computer vision. Whether or not the average person needs these features or not, it's hard to say. I'm going to address one of the concerns I have around there in a second, but it does have quite a few features. And that does tend to play into what I call top-down decision-making processes, even though it doesn't necessarily result in the best bottom-up experience, as we'll see in a second. But let's just make sure that we can actually accomplish what we're trying to accomplish and run the final analysis to see if we can even this little chart that I've prepared in Alteryx. And I just want to hover over, yeah, that's the frequency. If you recall, we proved that experience over time, there's a smaller percentage, or the ratio is smaller, of unscheduled extra time versus normal time, and the exact same pattern comes out in Alteryx. So we can see here in our first value is 0.749, and if we jump over to EasyMorph, we can see here right away that we're getting the same number. If it just comes up, there we go, 0.749. So it's the same result. And it goes to show that you can use any number of tools to get the same result. But the difference with EasyMorph is I find it, again, puts you into that psychological flow state. Now, the reason, again, is EasyMorph has very fast feedback. The visual metaphor is nice. But here's where the tools diverge. Alteryx doesn't actually show you the data until you drag out what is known as this browse tool. So if I want to see what came out of this final filter step, for example, I can drag this browse tool, but then I have to go back and I have to rerun everything. And now I can see the data out here. So this is, I would say, better than Qlik. PowerQuery is better in some regards in that it's always anchored this way, although PowerQuery is very laggy. So I think I kind of prefer Alteryx. But again, if you want to see what the data looks like for before and after any given step, you have to again drag out another browse step. So if I want to see what the data looked like beforehand, actually I want to see the rows that were filtered out. So here we go again, and I'm going to run it again. I can see actually it's quite nice. 488 rows have been filtered out, but I don't really have a sense of what impact does this have on my overall analysis? Like, did I filter out a bunch of rows that will, and by the way, I'm just filtering out, as you can see, records where there's no business ID. As I mentioned earlier at the beginning of this demo in the previous video, that I wanted to make sure that I only am comparing dispatch records where there's both a technician and a business. So it makes sense to filter these out, but does this have is this going to have a hidden impact that I'm not aware of? Well, that's where EasyMorph, I think, really shines. So if I go back to EasyMorph and I look into its the cleaning steps, I can see here that, again, I can see a before and after row count, and I can go into analysis mode, and I could start to sort things if I wanted to, sending and whatnot. But the reality is that what I really want is to be able to analyze this statistically. And to show you what I mean is over here to the right, if we see we've got this trend chart, and if I click before the filter and then I click after, and I keep my eye on the chart, I can notice that there's a change in pattern. You can see a little spike that's happening right here. So when I apply the filter, I filtered out all these rows around here. Now I've also created a crosstab version of this chart that also breaks it out by time type. And again, if I go before the filter, I can see on August 31st, there's 106 visits, and then after, they're all filtered out. So what's going on that date? So I can go over here, and again, it's very easy for me to build a histogram out of any given field. So I can just drag the field up here, and instantly I get a histogram. I can sort by the dimension, or I can sort by the count. So I filter on this August 31st, which is that spiky area that was filtered out. What does it look like from a technician standpoint? Well, I can see right off the bat that this technician over here is comes up the most frequently. So if I click on this person and then I clear the date filter, I get a sense of yes, this person really is over indexing on this date. So I might look at this technician and go, you know what, I think I want this person out altogether because it might be skewing my analysis in other ways that I'm not aware of. And I can just go in and instantly add this filter to my workflow. So I'm actually going to select the complement. So I select excluded, and then I now am going to add that as an action. And you can see down here, I went from an analysis into data development without any context switching whatsoever. So this is really powerful. Now I can do one last check. I can look at a more coarse grain statistic just to see, does this generally change my average total cost? And if I jump between the final filter and the steps before the filter, I can see it's negligible. So this bar here goes from 197 to 198. That's totally fine. It doesn't really impact my analysis in any meaningful way. So I'm just going to leave it like that, and I'm basically done there. So getting back to Alteryx, there's one last thing I wanted to show you that had quite a bit of a contrast, not just with EasyMorph, but with all of the other tools. And it comes back to this fuzzy match over here. Now, I'm going to basically show you what the issue that I ran into, and why these tools, or rather why tools can often get selected for the wrong reasons. So before I show you the issue, I just want to point out that I had to do this weird union thing in order to get this fuzzy match together. Normally, you would think of a fuzzy merge as involving joins, but in this case, I had to concatenate data. To be perfectly honest, I had to follow a number of YouTube videos to figure this out, and I still never really felt super confident on how this worked, although I did manage to get it working, and I suppose if it wasn't for the other tools, I wouldn't really know if it was working. But putting that aside, the other thing I found was it had a very high false match rate. And let me show you what I mean. So if I click in here, I can put a threshold, a match threshold, whatever I want. By default, it's usually around 80%. Here I had to crank it up to 91%. And if I run it as is at 91, so I'm going to sort on ascending, and these are all legitimate fuzzy matches. But if I go back and I just crank that down by 1 percentage point to 90%, which is still very, very high, and I rerun this, there's a match on Jenna Franks to Anne Franks. And that's a false match, and that's why I had to crank it up to 91 to filter out that false match. Now, that's not a huge deal, I suppose, but the bigger point I'm trying to make is, of all four tools, Alteryx, I struggled the most when it came to getting fuzzy match working, and when it did work, I felt it did rather poorly in the department of matching on names. But you can see how a consultant or somebody else who is sort of not an analyst necessarily, but is in charge of software selection, would choose this tool over the other four. And the reason they might choose this tool is that it actually has all of these specific business scenarios laid out for you here. So there's address and company, and of course name and phone, and so on and so forth. But the reality is first of all, are we sure that each of these options works that well? Because the name one didn't really work that well for me. But more to the point, the typical scenario of matching is, by the way, matching just names. And that's because most people are just matching across employee lists or customer lists. And that's because you'll have the same customers or employees that are onboarded in multiple systems, and the systems aren't always synchronized by IDs and whatnot. So it's this is actually a very common typical scenario that I'm showing you here. But a consultant wouldn't necessarily know that or distinguish, and might give, again, in terms of selection criteria, a higher score to a tool like Alteryx and a lower score to all the other tools that I just saw, even though those other tools were much easier to work with, and I think had a better result, especially if you consider the false positives that I ran into earlier, as I mentioned. So that's why you can often be misled with a lot of these fancy looking features. Yes, they often look good on paper, but are you really using most of these features on a day-to-day basis? And do these features actually even cover your most common use case scenarios? And in that case, I did find Alteryx was a bit lacking, especially around some of the data combination functions. I felt Alteryx had way more because you're combining data in all sorts of different ways and all the time. Whereas things like text mining and spatial, yes, they might come up from time to time, and there are definitely solutions, usually API based in EasyMorph that you can get to, but they're not the super common scenarios that you're running into, like when you see all of the features in Alteryx that are available to you. So again, you have so many of these transformation options in Alteryx that I've yet to run into a relatively common scenario that it wasn't already nicely covered. So again, a good example of that is we look at the deriving of the visit number, and you can see here it was really quick and easy to set up this visit tuple. I just selected enumerate groups. I just selected the group I wanted to enumerate in. Whereas in Alteryx, it was easier, I would say, than it was in PowerQuery for sure, and a little bit easier than Qlik. But it was still a little bit more complicated, much more complicated than if I compare it to EasyMorph. So I had to use this step here, and ultimately I had to create this expression. It wasn't too difficult to set this up, but as you can see, this code is a bit more cryptic than what I'm looking at over here. And this was just click, 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 and it was done. Over here, it took a little bit more brain power to figure this out. So in summary, the reason I really love EasyMorph as my favorite data preparation and analysis tool is quite simply because it has extremely fast feedback, it's oriented in the data, and there is no context switching between analysis and data development, which is quite extraordinary in my view. So I hope you learned something from these videos, and I look forward to doing more videos on data preparation, EasyMorph, and the psychology of flow. Thank you very much.